We want to differentiate this using the definition of derivatives, which is f prime of x equals the limit as h goes to 0, f of x plus h minus f of x all over h. So what we're going to do, we're going to start doing this. So basically, f prime of x equals f of x plus h. So that means instead of x, I'm going to go x plus h, and I have plus 1 minus f of x, which is x root x plus 1 all over h. Of course, don't forget to write the limit as h goes to 0. Now, this will give me, what can we do with this? So what I need to do to this, I need to multiply, instead of equal, multiply by the conjugate of this top. So the conjugate of this will be square root of x plus h plus 1. Instead of minus, it's going to be plus root x plus 1. And whatever I do to the top, I do to the bottom. So now, what I'm going to get the limit as h goes to 0. Now, when you're foiling this, you multiply this times this, you're just going to get x plus h plus 1. When you multiply a root by itself, the root will cancel and you'll get whatever's inside the root. Now, if you FOIL it, you go this times this and then this times this. You're going to have the same thing with the opposite sign, so they're going to cancel. So you could take a shortcut and just multiply this times this and then skip and multiply this times this, and you'll get negative brackets x plus 1. Make sure you put that in brackets all over. On the bottom here, you know what I recommend, that don't do anything to it. Just leave it as h times x plus h plus 1 plus root x plus 1. Next step is to collect like terms here. So this is going to be x minus x, which is gone, and then h, and then 1 minus positive 1 is going to be 0. So I'm going to have h on top, and remember limit as h goes to 0 all over. I have the h on the bottom here, and I have this root x plus h plus 1, and then plus root x plus 1. At this stage, what I want to do, definitely I want to cancel this h with this h, and I'm going to get 1 on top. And now you could start subbing in the 0 for the h, and therefore we'll get 1 over x plus 0 plus 1 plus x plus 1, which gives me, you don't have to write limit as h goes to 0. As soon as you sub in the 0 for the h, you don't have to rewrite that again. And you get 1 over, this is going to be just root x plus 1 plus root x plus 1, which gives me 1 over 2 root x plus 1. Just gonna remove that a little bit away from there. So this is 1 over 2 root x plus 1, because this plus this, they're like terms, so it just becomes 2 root x plus 1. And this is the derivative of root x plus 1 right there. If you want to check using the, once you move on and you start doing derivatives differently, if you have y equals, and I'm going to do that in a different color, could double check your answer, y equals root x plus 1. To take the derivative of this the other way, which is the chain rule and all of that, the power rule, first of all, you change this to y, and you make this as x plus 1 to the power of 1/2, because that's what the square root is. When you start doing y prime, you bring the half down, and you get x plus 1, still take away 1 from half, and you get -1. So that's how you take the derivative. You bring this down and then take away 1 from that. And then you go on the side here and take the derivative. What's inside? The derivative of x is just 1, so you don't even have to write it. And therefore you get 1. Since this has a negative exponent, it will come down and become x plus 1 to the power of 1/2. And as we know, to the power of 1/2 means the square root. So this will become 1/2 square root of x plus 1, which is exactly that. And that's how you do it the faster way. This is using the definition of derivatives to take the derivative of that. And you'll be examined on this formula right here. So again, if you like this, make sure you hit that like button and subscribe to my channel. Thank you for watching and see you soon. Bye-bye.